Hello everyone, today we're going to be looking at the 2026 F equals MA exam problem 5. This problem is relatively easy and it's about projectile motion. So let's start by reading the problem. A helicopter flies at a constant height h along a circular trajectory of radius r with constant angular velocity omega, continuously dropping sand. Ignore air resistance. What is the radius of the curve traced by the sand on the ground? So first of all, let's draw a diagram for the helicopter's circular trajectory. We know that the radius is r, and we also know that the helicopter travels at a constant angular velocity of omega. So first of all, we need to find out what direction the sand is moving once it leaves the helicopter. Well, before it leaves the helicopter, it's just going to be traveling at the same speed as the helicopter. So the instantaneous speed of the helicopter at any point on the circle is just tangent to the path. So this is the V of helicopter. And that is also the direction that the sand will travel in. And that is going to be equal to, from rotational kinematics, it's going to be equal to r omega. Okay, so we know that the sand travels this way once the helicopter leaves. And now the distance of the circle, well, let's say after the helicopter travels a full revolution, the sand will just, trace out a larger circle, and the radius is going to be this, r prime. And we can use Pythagorean theorem because the VH is tangent to the circle. So now r prime is just going to be equal to the square root of r squared plus this distance. So I'll call it delta x plus delta x squared. Okay, so now we need to find this delta x, and we can do so by using the fact that they gave us it's flying at a constant height h. So we can use projectile motion. Let me draw a diagram of this. So if the helicopter flies at height h and the sand comes out at v equals r omega, we need to find how far it lands on the ground. So this is delta x. Now, first of all, we know that delta x is equal to vt because it's constant velocity in the x direction, but we don't know what t is. So we need to find t, and we can use the kinematics in the vertical direction. And we know that in the vertical direction, t equals square root of 2h over g. So delta x is going to be equal to, and since v equals r omega, r omega square root of 2h over g. And yeah, that can be changed into delta x equals r square root of 2 omega squared h over g. And I change it into this because the answer choices, all of them have the omega squared inside of the square root. So now we can combine this into the final equation to find r squared, r prime, and it's going to be equal to square root of r squared plus delta x, which is r square root of 2 omega squared h over g squared. And this can be simplified into r squared times this. And we can notice that we can factor out r squared from this equation. So it's going to be equal to r square root 1 plus 2h omega squared over g. And that is going to be answer choice E. Thank you for watching, and please subscribe.